Hello and welcome back. So far we have introduced Python and got familiar with indexing, slicing, subsetting, and conditional subsetting. We have also seen that we can apply multiplications and division and other operations on the entire array, on the entire NumPy array with a simple line of code without doing any loop or list comprehension. We have also created NumPy arrays, but from the list. In this part of the lecture, we are going to create NumPy arrays from scratch, not necessarily from list. So we've been using np.array, and then inside the parentheses, we've been using a list to convert that list to a NumPy array. Now we are going to create a NumPy array from scratch. If you know the size of the array beforehand, which is the case for many of the application, there are commonly used functions that you can use. You can create an array of ones using np.ones, an array of zeros using np.zeros, an array of random numbers, or an array of fixed lengths within a range. We're going to learn these functions in this part of the lecture. So like before, we're going to import NumPy as np. And we should also note that if you want to get more information about, for instance, ones, this is what you have to do. You have to do help inside the parentheses np.ones. So it's going to tell you that these are the inputs. So you can specify the shape here, and it would return a new array of a given shape and type filled with ones. Now let's try to see how it does that. It has also examples for you. You can even try the examples. Let's start with even one of the examples. So let's try creating a 1D array, a one-dimensional array of ones as the example Python given us, and let's print its value. So it's going to create a NumPy array with length of 5. So it has 5 elements, and all of the elements are ones because we were asking for an array of ones with size 5. Let's see the type of this array. So for that you have to do array.dType. You can do this, and by default NumPy creates array of float 64. That also depends on the system you are using, based on whether it's a Mac OS or a Windows and what type of the Windows you have. But on my system it would be a float 64, meaning that it has 64 bits for one value is represented by 64 bits. You can be more explicit and set the dType. Remember here in the help, one of the inputs was shape, the second input was dType. So if you have a dType in mind, you don't want floating numbers and you want kind of save on the memory, you can do the following. You can actually use the same format, but now go here and add this second input and tell the function that I want array of ones. I want the array to be of size 5, but I don't want floatings. I can have less memory used here and use integer. If you do so, it's going to give you an array of 5 ones, and you see there's no point here, meaning that these are integer values. So you have an array of ones, a NumPy array of ones with length 5, which is all integers stored in it. So if you do arr.dType like we did top there, you'll get int64. So again, depending on your system, you may get int32, but it's integer 64. So that requires lesser memory compared to a floating point. Okay. You can also create array of ones more than one dimension. So you can create a matrix 2-dimension 5x3 using the same function. Here, instead, you have to do np.ones. And inside parentheses, instead of referring to one value, you are now referring to 2. The first one being the number of rows, and the second one being the number of columns. So it would create an array of all ones, and which has 5 rows and 3 columns. So this is how you would create a NumPy array with 2 dimensions. In many of the applications, you may also want to create an array of zeros. This is very common. You may have some numbers that you are trying to add values to that. Let's say some accounting numbers or the counter of some specific event, but you want that array to start with 0. This is where this zeros function comes into picture. So with the same approach, you can do numpy.zeros with s, and inside the parentheses, either refer to one number if you want a 1D array, or point to 2 numbers with the number of columns and rows. You can go to 3-dimensional and more than that, depending on the use case. But let's do just 1D of 5. So it's going to give you an array floating point again, because that's the default, of size 5 and all zeros. And again, if you want to only save integers, you have to specify as a parameter d type to be equal to int. If you do so, you'll get 5 zeros, but this is going to store array of integers. So that's why one of the reasons that NumPy is fast is that from the get-go, you would specify the type and the length of this array. So that would make computations more optimal and efficient on these type of NumPy arrays, and hence make it faster for the type of applications that we are interested in. You can also create a range of numbers. If you remember, for the list, we had this function which we called range, right? If you do range 5, it would create a list of, basically if you do list of range 5, it would create a list between 0 to 4. You could also do list of 1 to 5. That would give you a list starting from 1, incrementing by 1, excluding 5. A similar function for the NumPy library is the so-called arange. So that's basically NumPy arange. And here you can specify 3. For instance, if you do so, it's going to give you a NumPy array of size 3, starting with 0, ending in 2, excluding 3 again. You can do the same thing with arange, and if you specify 3.o, meaning you're kind of implicitly telling the Python interpreter that you're interested in a range, but now with floating point values. So it's going to give you a very similar NumPy array, which is capable of storing floating point instead of integer. So here, if you don't mention a 3 as a floating point, the default is integer, as opposed to when you do ones or zeros, the default was floating point 64. Similar to range for list, you can also create NumPy arrays indicating the starting point of the range, ending point of the range, and even steps. So if you want to create a NumPy array where the values are ranging from 3 to 35 and with the increments or steps of 2, here is what you have to do. You have to do np.arange. The first input is the starting point, the second is the end, and the third input would be the steps. If you do so, you're going to get a NumPy array of integers starting from 3, ending in 33, excluding 35. So like Python list, the end of that range would be excluded, and the steps are 2. So you have 3, 5, 7, and so on and so forth till 33. When we talked about NumPy, and in the very beginning of the previous lectures, we talked about how to create random numbers using the random library. Inside the NumPy library, there's also a random generator NumPy array. So if you want to create a NumPy array of random numbers, you have to do np.random. So this is inside the NumPy array, and you can do rand int if you want integer. You have to provide a lower bound and upper bound here and a size. So if you want to create a NumPy array, and if you don't mention the lower bound, the first input, the only input would be the upper bound only. So here you are creating a NumPy array of integers with length 10 and with the upper bound of 2, meaning that you only have 0 and 1. So these are random binary generator kind of, because you only have 0 and 1, and the size would be 10. So you can also do the same thing. If you want to create a random integer between, let's say 3 and 4, but the integers they're integer numbers, right? So they are integer numbers starting from 3, ending in 4 with the size of 10. Let's see what you get. You only get 3 here, right? Because obviously the upper bound is excluded, like the same thing you had with arange and range in lists. But if you want, let's say 3 and 4 to be included, you have to do 5 here. So this is a random generator of the numbers 3 and 4 of size 10. Here, due to the random, here, because it's random, you see more 4s than more 3s, but you repeat that. But if you repeat that, you would see other scenarios. Now you have more 3s than 4s, but on average, you would get same number of 3s and same number of 4s with the same likelihood, because it's a completely random generator. You can also create arrays of two dimension using the NumPy. So if you do np.random and you mention 3 and 4, right, inside square brackets, it's going to create a NumPy array, a 2D NumPy array with 3 rows, 4 columns, and by default these numbers are between 0 and 1. So you can use np.random to create floating point random numbers. So this function random will be used to create NumPy 2D arrays with these many columns, with these many rows and these many columns. And by default, these numbers are between 0 and 1. So you would see floating points between 0 and 1 with this size. So you use np.random to create this type of NumPy arrays, depending on your use case, as opposed to random that you had here. The other application that you may have is that you know the length of the array or the points. So you know that you want to create an array of length 20. You know the starting points. You know the starting point, you know the end point, so you know the lower bound and you know the upper bound, but you don't know the step size. But you know how many components or elements you want within that range. So here the goal is to create 20 numbers equally spaced between 1 and 10, right? So you want 20 numbers between 1 and 10, including 1. So you want a NumPy array of 20 values between 1 and 10, which are equally spaced. For that case, you have to use the so-called linear spacing function, where you indicate the first input to be the lower bound, second input to be the upper bound, and the third input, when you use linear space, the third input refers to the number of components you want and not the step size. So keep in mind that the third input serves a different purpose than the third input for range, arange, and so on and so forth. If you do so, you are going to get a NumPy array. You're going to get a NumPy array starting from 1, ending in 10. In this case, 10 is also included. This is a 1D NumPy array. Don't mistake this with a 2D NumPy array. There is no rows and columns. It's just that because due to the size of the screen, it has divided this into this type of shape. But it's a 1D NumPy array, starting at 1, ending at 10, and linearly divided this space between 1 to 10 into 20 chunks. So it would be 1.47, 1.4994, and as you can see, the spaces or distances between the components is approximately around 0.47. So this is very much used when you want to plot curves where you want this to be your x-axis or your y-axis. So in this lecture, we got introduced mostly into how you create NumPy arrays from scratch. There are situations where you may want to create a NumPy array of any dimension 1 or 2D dimensions, of all ones or all zeros, or a range of numbers or random numbers. And we got familiar with the functions that you have at your disposal, and you can even use help for that matter, to create those NumPy arrays from scratch. This comes on top of the way that you have learned in the previous lectures, where you convert a list into a NumPy array and create a NumPy array from a list. For exercise and for your own learning, I would encourage you to also go and find what would np.full, tile, I, and rand it would do. Actually, we have covered this function in one of the steps in this lecture, but I would like to invite you to do this as an exercise and see that what these NumPy functions would do. It would be a good warm-up as well.
If you've made it this far in the video, give us a like, a share, subscribe, hit the bell icon, tell us what you want to learn next in the comments, and then wait. Or skip the wait and become a data scientist in just 12 months with the Executive PG program in Data Science from IIIT Bangalore, powered by upGrad in collaboration with experts from Meta, Myntra, and LinkedIn. Over 20,000 working professionals from over 65 batches have already done this course.